There's no reason not to do it. There we go. Record it now. Okay, so let's share screen. I'm also going to go over how to do how do you call it? We'll start from scratch. We'll start from the basics. We'll start from how do you sorry, I just need to move everything for Zoom. How do you start out all of this? How do you create a project? Because I know this is one of the things that early on people struggle with a little bit, especially since while IntelliJ is great and all, this intro interface can be kind of weird because it asks what kind of frameworks you want, and because you guys are like brand new to the language, frameworks aren't going to make any sense to you. So I'm just going to walk you guys through. So you click new project, and you want to make a new project, and I recommend put the folder. You just say, oh, you skip these. You don't need any additional libraries or frameworks. You're just doing base Java, whatever version. In this computer, I have version 14. You don't need to create it from a template. Don't worry about that. Then you come here, your project name. Your project name should be all lowercase. Just naming convention wise is generally not a bad idea. It's generally a good idea to have it be lowercase and either use hyphens or preferably underscores. Generally tend to cause less errors. Or you can do it camel case, which is start out with a lowercase, and if there would be a space for like another word, like if I was going to say my name is Turk, that would be writing my name is Turk in camel case. In this case, I'm just going to call this one CSC 211 demos, and we've created the project. It should pop up here in a second. There we go. I'm actually going to keep music going because it's really weird to me to be coding without some kind of like ambient music or noise in the background. It's just really quiet. Okay. Why are you so slow, IntelliJ? I swear it's not this slow on my other computer. Okay. So before we get started, let's talk about what all of this is. So in this folder, if I go to my Windows File Explorer, if I right click on this, and it should say open directory somewhere, open in Explorer. There we go. In my computer, here's the path to this folder. And inside of the folder, I have the .idea folder. Quick fun fact, when a folder name has a dot in front of it, usually it means it's like supposed to be a hidden asset or a hidden folder. Usually you don't want to go messing with it. All this stuff is just stuff specifically for IntelliJ to use. And same thing with the this CSC at 211 demos.iml. I hate that Windows 10 does this. That's really annoying. So inside is a source folder. This is where you'll keep your source code, hence the source folder name. All of our code, all of the Java files you write will go here. Now, in you guys' case, you're writing code at this point that's just a single class, single file. So whenever you submit to me your projects, you're going to go File, Export, project to a zip file. It's going to take this entire project, put it in a zip file, and I'll be looking at your source code, your source folder. There's only ever going to be one file in there, but that's okay. The reason why I have you do this is because when I have you zip up your files, I make it so that you guys name your zip directory is a very specific thing, so I know whose thing is that I'm opening, and it makes creating easier on my part. Anyways, here we go. We're going to create a new file. Now, I can create a new file by saying Control N. Oops, that's not. Yeah, there we go. I have to right click it in Windows. And we'll name this something. When you name classes in Java, classes are also like your files. When you name classes in Java, the naming convention for that is to use Pascal case, which is upper case like this. So if I wanted to say my name is Turk, that would be writing my name is Turk in Pascal case. It's exactly the same as camel case, except the first letter is capitalized instead of lowercase. In this case, I'm just going to name this one chapter 2 lab demos. Actually, I'm not going to put demos because these are all chapter 2 lab. So what you guys kind of learned about last week in 210 was the very basics building block of not just Java, but like coding in general. Oh man, this is slow. So first things first, whenever we go to code anything, we need to think about what our entry point for the program is. What is our, where's the main method going to be? The main method is the entry point. It's always going to be written like this, public. And this public, and I'll kind of talk about what all these words mean, because I know when I was first learning it, I had no idea what these words meant, and I just kept writing them over and over and over. Somewhere along the way, somebody tells you what it means, but it doesn't stick, so I'll be sure to address it from here. Public is an access keyword in Java. It basically just defines when all your files are working together, who can access it. Right now, because we only have a single file, the access keyword doesn't really mean a whole lot. Static means there is only one instance in the whole program. This thing will only exist once. You can have multiple instances of something, multiple instances of a single file running at any given time, but static means of this particular thing, there can only ever be one instance. So everything inside the static method will be shared. Everything will be like, it's basically saying everything inside of this block that we're about to create, give it the static keyword, meaning there can only be one instance. And again, further down the road, we will talk about more of what instantiation means and how you can have multiple instances of a single file. Does everyone know what I mean when I say the word instance of something? Like when I say there's an instance of something over there. Like, for the example is, I have multiple mugs. This is one instance of a mug, right? I can have multiple mugs back in my downstairs in my kitchen, but this is just one of many instances of mugs. You know, I don't have a different mug at my desk, but you guys get the picture. But again, this might be confusing now. We'll get more into it later on. Then the next keyword in here is void. Void defines a return type. Because as a main method, we don't return anything. So we just put void. And then the last but not least is the method name. Now, because we're using a keyword name in Java, we call it main. We can't really call it anything else, because if we were to call this main method, our program wouldn't know where the hell the entry point is, because main is a reserved word. Main method is not. And main is reserved to know that this is where the project comes into. Next, we have to define a parameter, string args. And what's before I go further, this is the basic formula. Oops, that's not what I didn't mean to do that. This is the basic formula for a main method in all programs. All languages have a main method. All languages require some kind of entry point defined by the word main. It's a static instance method, meaning there's only one instance that exists of it. And it always has a variable for the arguments that you pass to the command line. Again, this is something we'll learn more about in a couple of weeks. And then you put the blocks, and bam, there's your main method. This is our main entry point. Last week, you guys should have talked about the different primitive data types. Who can list out for me the primitive data types? List them for me. What are the different primitive data types? You guys remember? Int, yes. What else?
Double.
Yep. Let's start this way. Let's list numeric ones first. What are some other numeric? Yeah, float, byte, long. Yep. String is not a primitive type. Nope. What about some, we'll call them alphabetic. Char. Yeah, char is the only one. Byte actually, it's technically a numeric, but it's a very specific kind of numeric. So why do we have these different data types? What are they? Oh yeah, then there's Boolean. Correct. Boolean stands in its own category. Binary. And it's binary because it's one or the other, right? It's true or false. It's 1 or 0. So why do we... Let's look at the numeric, because this is the one where we have a bunch of different types. Why do we have so many different types of numeric data types?
I believe that has to do with a range of numbers.
Yes. Did anyone talk to you guys about how that range is calculated? Let me give an example. Yeah.
Not really.
So, does everybody see the whiteboard? It does have to do sort of with memory allocation. Everybody see the whiteboard?
Yes.
Okay. So in computers, so when we have our Java code, right? Let's say here is our Java code. We have all this human-friendly readable code that like humans can read, right? What happens is when we say run, the Java compiler takes this code and translates it into a machine readable, and I'll put like 1s and 0s on here, even though the file itself is not 1s and 0s. It's called a class file. This class file is machine-friendly code. If you ever compile code and look for this .class file, you won't be able to read it because it's not really human-friendly readable. You guys, who's not seeing any drawings? Oh, you guys aren't?
Yeah, it's still blank. It's still white.
That's weird. Let's try this. Let's go back to the whiteboard. Can you guys see it now, the drawing?
Yeah, we see it.
Yeah.
Okay, cool.
We can see it.
Awesome. Apparently when I drag it to the other monitor, you guys can't see it. Weird. So when we have our human-friendly Java code, this is our .java file. And, there's some code in here that humans can read. There's something called the Java virtual machine, the JVM. And we'll just make it like a little monitor, right? This is the JVM. This is what actually runs your Java code. This right here, the JVM, is what runs your Java code. In order for it to do that, we need to translate it into a kind of code that's readable for machines, because machines don't read the actual human-friendly code. You have a compiler that translates it to binary or whatever format that is readable by the machine. So when we write it into human code, we need to translate it into some kind of binary-ish file. And I say ish because Java is unique in that it's not an actual binary file. And then that way, the JVM can read it. And this is what happens when you hit run. Whenever you hit run, compile and run on your program, these are all that happens. So the Java compiler, or we'll call it, as we refer to it as Java C. I don't think you guys saw the drawings earlier.
You know what I think it is? I think it's that when you stop sharing and then share again, we can see it, but we can't see you draw stuff while sharing.
That's so weird.
Yeah.
Okay. Do you guys see the drawing now?
Yeah, we see the JVM.
Yeah.
There's like a little file on the left, Java, and then there's the Java C, then the 10101. Anyways, your Java compiler translates your human-friendly code into what's called a .class file, which is readable by the Java virtual machine. And that's how code is run. This is why there's certain rules we have to follow about what to do. As far as the or how we name things, because the Java is very particular about how we do stuff. So things like, let me go back to my sharing my code. Things like making sure our class name is the same as the file name with capitalization and everything. It has to be exactly the same. Otherwise, you're going to get a compilation error, meaning your code's not going to run and you're going to lose half your points because of that. That's something very, very important to note because I have a lot of students mess up with it. Keep that in mind. As far as defining the range, so in a byte, it is comprised of a certain unit called bits. When I say bits in machine language are a 1 or a 0. Each 1 or 0 is a bit. And that's like the building blocks of machine language. So a byte, I believe, is 4 bits. 10101, that's 4 bits. And what's neat about this is has anyone learned about binary? How to read binary?
I've heard about binary, but never know how to read it.
Okay. So binary works in powers. Yeah, binary works in powers of 2. So this 1010 can be used to represent a value, a numeric value. Basically, the way you calculate it is these are indexed from right to left, starting from 0. So 0, 1, 2, 3. And what this basically means is, if I remember my binary right, is 2 to the 3 plus, or 2 to the 3 times 1 plus 2 to the 2 times 0 plus 2 to the 1 times 1 plus 2 to the 0 times 1. This whole thing up here, these are like the indices that we use to number it, comes out to this, which comes out to being 9. So 1010 is equal to 9. So given assuming we only have a byte, which is 4 bits, or yeah, just if we have 4 bits, what is the greatest value that we could represent here? Anyone? Given this, what is the largest value that we could represent with 4 bits?
8.
Is it 8? If everything is a 1, meaning that's the max,
It is 8 would be 1000.
No. I'm asking 111. Yeah. This is the max because this is all of them are 1s.
Sorry, I was just doing the calculation in my head. It would be 16.
Yeah. 8. Yeah. 8 plus 4 is 12. Plus 2 is 14. Right, hold on. 8 plus 4, 12. 14, 15. Be 15 actually. I believe. God damn it! Now I'm doubting myself. Hold on. Yeah, 15. I was pretty sure it was right, but I was like, hold on. 16 is a special number of powers of 2. But yeah, it is actually 15. So what happens, the reason why this is important to know is because even though int and long are technically the same, they represent integer values, whole numbers, positive or negative. Even though these represent the same thing, they have different amounts of, they have different levels of bytes allocated to it to represent it. So the range is different. And I'm not going to go over exactly the ranges because I genuinely don't remember them off the top of my head. It's like minus 254 to plus 255, something like that for int. There are 255,000, something like that. I can't remember it. But the numbers 255 and 254 are involved just because I know binary stuff. Same thing with double and float. Double and float are technically the same. They represent the same thing. They represent a decimal number, right? And the difference between double and float is how much space is allocated to represent the decimal part. Floats, I believe, have more space allocated than doubles. Or no, sorry. Doubles have more space than floats. Which I believe they get their name because they have double the amount of space allocated to represent the decimal. But everybody follow me so far?
Yeah.
Cool. It is important to know that because in this project, there will be a portion where you will need to make this distinction. And we'll go over that when we talk about the lab in a little bit. So the next big thing to talk about, binary Boolean. That'll come up more next week when we go into if-else statements. As you guys, I think you guys are doing that right now in 210, right? You guys should be learning about conditional statements. If, else, then, switch, etc. Yeah. So Boolean values become a play there, and we'll talk more about that next week. You have chars, and chars are really interesting because chars, you can represent them with both a you can think of them both numerically and alphabetic. So what I mean by that is if I have a char, c is equal to, we'll just give it the value of lowercase c, and I say system at println c, and then I say c++, meaning I incremented c by 1, and then I by the way, fun fact, the way I did that, if you write s out and then you press tab, you'll get system.println, which is really neat, nifty little shortcut in IntelliJ. And I print C again. If I run this thing, and one thing you'll have to do, especially if you are going to have multiple main files in one thing, you'll have to make different configurations for it. I'll just call this chapter 2 lab. And the main method will be in the chapter 2 lab. Say OK. And if we run this program, I'm just going to print out C and then something else. Yeah, NetBeans sucks. Don't use NetBeans. I mean, if you're used to it, sure. But oh, look at that. We incremented C. That's pretty cool. What if we had char of let's see if this will work. 52. Will that work for me? There we go. I put in char 52, but oh no, apparently char 52 means 4. This is because there's a whole table of ASCII characters that the char is based off of. And we can actually see that if we go, if I open up Google and we go ASCII character table. If you go to ASCIItable.com, as the first one. Come on. Come on. Oh, I know why it's going slow, because I'm recording on Zoom. It's the same on my other computer too. Things tend to slow down. There's also like a shit ton of data. So the decimal column is what you're interested in. And this is the character that's going to be there. So if we look at line number 52, that gives us the character of 4. Right? Because characters are just a single character. But we can use these different codes to represent them. We could use hex, we could use decimals. By default, in this, if you just put a numeric number, it's going to consider that as a decimal. But let's try an experiment, because that's what this class is all about, right? Experimentation. So let's say if I put 2F, right? Or let's put 2E. Yeah, it's not going to like that. Yeah, so we'd have to probably use some other data types that I don't want to look into right now because it's going to be confusing. But this is a really, really cool property of character, because I'll tell you why. Somewhere down the line, one of your 210 teachers or some of the teachers are going to ask you a question, or in an interview, you'll get asked this. It's not an uncommon question, where you'll be asked to convert, to track from capitals to lowercase letters. Some kind of project is going to have you do this, and you can't use the 2 lowercase or 2 uppercase methods. So what you're going to end up doing is converting each individual character to a char, getting the code, and knowing what the difference is between the uppercase code and the lowercase. So it goes from 65 to 97, which means the difference is 32. To go from lowercase or uppercase to lowercase, you add 32. To go from lowercase to uppercase, you subtract 32 from the char. Now, obviously, if you start getting into these kinds of characters, like special character, that's going to be an issue, but that's not a problem because we're just going to assume that it's all alphanumeric, and we'll have conditions in place to check for if it's a punctuation or something, so we don't mess up the initial text. But yeah, this table, really important to not memorize it, but just understand how chars work in relation to this. I encourage you guys to play around with this a little bit, play around with the decimal codes to chars, just do some little experimentation of your own in your own IntelliJ environments. And yeah. The next and kind of last thing that you'll need for this lab to think about is the scanner. So there's a lot of really cool stuff in the Java library, which are custom classes, custom objects that have been built over the years and integrated into the Java main library that you can leverage to make your coding easier. You'll see more instances of this. What about the time calculation? Well, it's just simple math, right? Are you asking for the you're asking for the homework, right? For the lab?
I'm asking for the lab. But one thing I noticed was when I was just following through, just using basic math, sort of like how many weeks are in month and everything else, it started to break down and started to go off of what your example was.
How many weeks are, well,
because of leap year and other stuff, it starts to screw with the time.
How many weeks are in a year? It's 52.
Okay,
Sorry.
52.
If anyone's worked an office job, they know exactly how many weeks are in a year. It's 52 weeks in a year. I should have been more clear. I think I have it somewhere in that there's 52 weeks in a year. But yeah, there's 12 months in a year, 52 weeks in a year, and you go from there.
Got it.
Keep in mind, if you're below a certain age, you can get by with this with using integer. But because I'm an old ass fart, when I go run your program, I'm going to run into weird errors if you guys use integer. So you do need to think about that, because especially think about like when you get to the minutes and seconds of how old someone is. That's going to be a really big number, potentially. So do some experimentation on your own with different ages. Guess my age, guess however old you think I am. Use your parents' age actually is a really, really good way to test your program here. Use your parents' age, use your grandparents' age. And you'll know if it's wrong, because if you go outside the range, you're going to get some really weird negative number or some really small number. Yeah, that's how you'll know you're wrong. All right, that's how you'll know you're using wrong data types. The idea with this project and any code we write is to really future-proof it and proof it for all cases. It might work for you, it might work for your brother and sister who are only a couple of years older or younger than you, but what happens when your grandmother uses it? She might get some really weird numbers. So test everything out, test a bunch of different ages out, and make sure it passes. I might in the future include some programs that test your program for you, probably like a grader program that I'll run that'll just give you, you can keep running it till you approve it, you get past the test cases, but I didn't have it ready for this one, unfortunately, which ironically, this would have been the easiest one to test for. Anyways, I digress. Let's get back to scanners. So because there's so many cool stuff in the Java base class so that you don't have to do things yourself, like for instance, you don't need to use scanner technically. You can try to use very, very basic level Java system commands to get input from the user, but you don't need to do that. It's easier to just say import Java util scanner. Fun fact, if you say import, first rule, these imports need to be outside of the class. you need to make all your import stuff above the class. In the same file, outside of the class. And once when we've imported it, this just means we have access to the code. We still need to create the object. So we're going to create an object of type scanner, and we're going to give it a name. I prefer to call my scanners SC, but you can call it whatever you want. Equals new, meaning we're creating a new instance of the scanner class, and we're interested in the system.in, the input stream, meaning this scanner is going to be listening for user inputs. Scanner does many things. In this particular case, we're going to have scanner listening to the input stream from the system. And then we're going to ask the user for something. What is your name? SC, or let's say string name equals SC dot next line we're going to use. So if I stop here, IntelliJ already suggests a bunch of different methods that I can use. And you guys can see kind of a pattern here. You got like next line, next byte, next double, next float, right? These are all returning a data type, a certain data type. So we have to think about what data type we're expecting for this variable and pick the proper next method. In this case, it'll be next line because that returns a string to us. There was another one in there. That's just next. That also returns a string. The difference between next and next line is next will only take the next full word. So let's say your user writes out a sentence like, my name is Turk. It'll only grab the first word and leave the rest of it in the scanner buffer, which will mess with further stuff, which will mess with things in the future. When you want to grab a full line, it's generally safer, unless you're doing something very specific, to just use next line. And you can try to play around with it on your own and see what happens when you use SC next instead, but I'll leave it here for now. And then we'll ask something. For now, I'm just like putting it in. Actually, there's no reason to put it in comments. Whatever. Print statements. What is your name? How many hours have you sunk into Cyberpunk? And then add a string. We'll say integer hours equals sc.next int. And then I want to grab another string from them. Who is your favorite NPC in that game? String NPC equals sc.next line. Now, there's going to be a really interesting bug that's about to happen right here. So let me run, and you guys will see what happens. And we'll just say, I'm not going to print out the results. We'll just leave it like this. What is your name? Turk. How many hours have you sunk into Cyberpunk? Is my Steam open? Nope. I think somewhere like 250. And then, oh, it didn't. It skipped when it asked me who my favorite NPC is. This is something that you guys will run into in this project, because I think I've specifically set it up so that you do. If not this one, definitely in future ones. And it's something very important to be aware of. Did you guys notice how it didn't ask me for this next string? It just skipped. Did you guys notice that?
Yeah.
Okay. The reason why that happens is when, and this is what makes next line unique to everything else. What scanner does is it listens to the system input buffer. So when the user types something out on their keyboard and hits enter, so if I were to type, like, in the example when I typed Turk and I hit enter, you get this. This is called a new line carriage character. This basically creates a new line. And this is what makes next line so unique, is because it is the only scanner method that will read through the system input buffer up to and including the new line character, meaning after scanner.nextLine runs, that that input buffer is gone. Or sorry, that new line carriage is gone from the input buffer. So, step by step, here in the code, the user types this in, and we'll just call this system input buffer, has this value in it. And then after they run, after this, system input buffer, I'm going to start calling that SIB. Now, here what happens, oops, our SIB has the value of, and I'm putting it in double quotes. Know that it doesn't necessarily mean it's a string. It's just to represent this is where the input buffer starts and ends. And I put like 205 or 250, right? And then I hit enter. That leaves another new line carriage. Actually, I misspoke. This is somewhat accurate because this is just basically a stream of data, a stream of bytes in the system input buffer. And then the scanner just converts it to the data type that we're looking for. So in this case, after it finishes running, in the input buffer is that, right? There's a new line carriage in the input buffer. So when we get to this next line, there's already a new line carriage in the buffer. So instead of asking the user for input, scanner just clears it because it's like, oh, wait, there's already the new line carriage here. So NPC has the value of new line. The way we combat this is we need an extra next line to clear out the input buffer. And we only do this, clears the new line carriage from input buffer. Only need to do this when going to scanner next line after using another method. So if we're using like sc.scanner.nextInt, scanner.nextDouble, scanner.nextByte, scanner.next, anytime we go from using those to next line, we need to clear the new line carriage from the buffer. Did that make sense? I know that's like a really, really confusing thing, especially for like newcomers. And it's really, really important that you guys kind of get that because it's going to solve a lot of bugs you have in the future. I guarantee you at least one of you is going to ask me a question about that in the Discord later. So if you don't understand, and it's okay if you don't, I will try to break it down with visuals and other stuff. Open the precedence window. Give me a thumbs down if you did not understand it. And you want me to explain it again. Or like raise your hand if you want me to explain it again.
Can you go over that one more time?
Yeah,
if
sure.
you don't mind.
Yeah. Let me pull up some visuals too. Since for some reason you guys can't see the whiteboard, we'll just use paint. Okay. So we have what happens with scanner is we have something here called the system input is the same outcome achieved if instead of the new line carriage. No. That is a good question, Jamie. That is not the same method because the system out print, it's on right. Sorry, let me gather my thoughts. If we just look at system.out, this is the output stream, right? But scanner listens to the input stream. So putting stuff to system.out does not affect what's in the input buffer. It's a very good question. Just know that there are two different, it's like two lanes on a freeway, right? There's the input and the output. Output is what goes from the program out to the console. Input is what goes from the console into the program. The problem is right now we have a think of the new line carriage like a, in this case we refer to it as like a traffic jam. There's a traffic jam in the input lane. The output lane is clear, so we don't need to change anything in the output lane. The problem is in the input lane, so we need to address that. And the way we do that, come back to the whiteboard, is this is our system input buffer. Whenever a user types in text to go to the program, this is coming from the outside in, their text gets put in here. Whatever they write, whether it be a number, whether it be text, anything. And then when they hit enter, we get, now I'm going to use a different color for the new line carriage. We get this new line carriage. Okay? With me so far, Jamie, and whoever else asked about going over it. You guys with me so far on this? Okay.
By carriage, do you mean it just tags along?
New line carriage is just the name for this very specific character. That's all it is. But yes, when they type in text and they hit enter, this whole thing is in the input buffer. Whatever text they wrote plus this specific character. Does that make sense?
Yeah.
Okay. So when our scanner, we'll use blue, when scanner works and it runs a method, all that method is doing is it's some pre-coded behavior. In this case, when we use the next line, the pre-coded behavior for that is that it's going to read whatever's in the input buffer up to and including the new line carriage. So when it's done, this whole thing gets removed. Now, and this is, we'll say this is next line. Next line. Now, what happens if we use something other than next line? What if the text we get is a number 42 from the user, and then they hit enter, right? And then we use the, because we were expecting an integer, we say next int. Well, the next int only reads up to the new a numeric value up to the new line carriage or some other delimiter or space. Delimiter just means like some kind of a separator. It's only going to read up to the next space, enter, whatever, right? It's only looking for just the first number that it could find. So it finds this and it clears it out. But that means there's still a dangling new line carriage in the buffer. Now, if we keep using next int several times over, that's not a problem because next int knows to ignore this. It's not included in its behavior. But next line is specifically looking for this thing to tell it when it should stop reading. So if the stop command is at the start of the buffer that it reads, it's not going to read any further, right? Does that kind of make sense?
That was a very good explanation.
Okay. I'm glad you guys got it. So
there's no other way of clearing that?
Correct. You have to use an extra next line like we did over here. You have to call this extra next line to clear that out. Because now if we run it, Turk 250 Jude, right? Now it works as intended because we've cleared out the stop sign that was lingering on the freeway. Bad analogy, but you know, that's in the case of the next line, that's how to view the new line carriage. And the new line carriage happens anytime the user presses enter. And for the user to submit their input to the scanner or to the system buffer, they have to press enter, right? That's how it tells this command line over here that, hey, I finished entering in my text. I'm hitting enter. That's the end of it.
So why does next int not just take care of that for you?
Just because that's how it's programmed. Because in nextint's case, you can't put a new line carriage into an integer. If you tried to convert this whole thing with the new line carriage into an integer, the program would break. It wouldn't work. Because
that's not what I'm asking. I was just because next line is sort of a built class for, and you've got next int and all this other stuff. Why not just have it when it sees that it just pulls it off the stack with it and just erases it?
My guess would be, like I said, you can't convert a new line character to an integer. So the authors of Scanner just said, ignore that part. That would be my guess. As far as what the actual reason is, I couldn't tell you because I didn't write the Scanner library. But it's one of those things that it is what it is. And really, it's just these are like different purposes, different stuff. I mean, I guess maybe the Scanner users expected you to just use one or the other and then convert it on your own. or just be aware of this hiccup and deal with it accordingly. It's a relatively minor issue. Just know that it only happens when you're going from not next line to using next line. And that's, yeah, that should be it for this. You guys should, at this point, have all the tools you need to be ready to take on the stuff in the lab. There are certain questions that I didn't go over here in class on purpose because I want you guys to get used to using Google to look it up. So for instance, I believe one of the requirements for the lab is to print out the user's name in all capitals. And actually, you know what? While we're on that, let's just go over the lab right now. The Java file name, you have to name it over calculator.java. Thus, your main class name will be main over calculator. You're going to ask the user for these 4 metrics about themselves. I have a link to the scanner documentation. I encourage you guys to get used to reading these, the Java class documentation. This is really, really important. You're going to be using this a lot in your future endeavors in Java. You'll be looking up how different classes function, the different methods they have in them and what they do. And in fact, I don't remember who it was that asked about why next line and next int work the way they do, but reading into them over here might answer some of your questions if you're curious. There's also a cool different features called has a next int. All this stuff I encourage you guys to read over it. And if you have questions, feel free to ask me in the Discord. By the way,
I see those are expandable links. So if we click that, it will go more in detail about it, or
it'll jump you down to over here to later. All the stuff is written here at the bottom. It just jumps you to the specific section that it's at.
Oh, awesome. Thank you.
I go back. Yep. There were 1 or 2 of you guys emailing me homework questions. I would really, really prefer you to ask in the Discord. Don't be afraid to ping me in the Discord. I will answer. I usually have my Discord on mute, so I don't get message notifications the second they appear. But if you guys have a question that requires my attention, just ping me. I do check the Discord from time to time, but if I miss something along the way and you don't want it missed, ping me. But I know there was some confusion about the pre-lab too. You guys didn't have to write any code for that. It was literally just write me instructions in the text editor. Anyways, back to this. Once we get all the data, you need to do these calculations, and I even give you hints. There are 52 weeks in a year, 7 days in a week, etc. Then you're going to calculate the body mass index. So I know here it asks the user's weight in meters. This is literally just so they have what do you call it? This is literally just so that you get used to using doubles. You don't need to do any kind of pound to kilogram conversion here for the BMI. Literally just use the weight variable and the height variable. I don't care that it's inaccurate because we're using metric and imperial system. It doesn't matter to me. You don't need to do any kind of extra conversion here. Literally just plug in this formula. And the squared is going to be, and I gave you a little note here, you cannot use, this is called the caret. You cannot use the caret symbol in Java as exponent. There's going to be something else you need to use. Again, these are things that you could just Google. How do I do exponents in Java? And literally the first link will give you the answer. Yeah.
I noticed that there's a possible error in yours for the days out in your example. That's how many days if you calculated it with 364 days, not 365.
Just use 365. I don't care about leap year. I'm not going to make you do that calculation.
Well, no, I just noticed on your sample output, it comes out to 102. Yeah. So 10,220 should be how many days old it says you are. And yours is off by a little bit.
Okay. Well.
Yeah, I was pulling my hair out while I was working on
Gotcha.
this.
Yeah,
just a few seconds
the
ago.
sample output is not necessarily you need to get this exact answers, and it doesn't necessarily mean my code is right because I write this stuff really fast. This is literally just I want you to format your output like this. Don't worry too much about the specific numbers. Just worry about, especially the output here at the very bottom. Format it like this, because I will take off points if you don't format it similar to this. Oh, and then there's going to be typecasting. Typecasting is another thing I'll go over really, really quickly. let's say I have a double D is equal to 2.14. Okay. And then I want to say int casted D is equal to int D. What's happening here is I'm telling Java, hey, I know D is of a different type and I know what I am doing. I want you to convert the D into an integer, meaning chop off this thing at the end. What that means is, actually, hold on, I'll ask a question here in a second. We'll just call this pi for now. And then we'll have another one here called double, another, we'll just call it x is equal to 2.7 or 2.6, and int casted x is equal to int x. What do you guys think? And you know this will be a good place to show off the debugger. So when what value do you think casted D is going to have over here? I'll call it casted pi. So what happens when we typecasting is literally this. Is us saying, hey, I know this variable has a different value, is of a different type. I want you to convert it. This is basically telling Java, I know what I'm doing. Don't worry about any kind of possible implicit conversion errors. Ignore that because I know what I'm doing and I want you to convert this to this other object or this other type. Mohammed, you're correct. It will be 2 because all that it does is it just chops off this decimal at the end. How about if I cast x? What if I typecast x to int? What is its value going to be? And if you guys don't know, don't worry because we can just run it and find out. You don't need to know off the top. Yeah, it's going to be 2 because it just chops off the decimal. Exactly. This leads me into the next thing, the debugger. So in IntelliJ, in a lot of IDEs for Java, you have this really cool feature called the debugger. The debugger allows you to step through the program as if you yourself were the computer. And you can put what's called a breakpoint at a certain line in your code saying, hey, while you're executing, when you get to this line, convert to debugging mode and give me the controls. So you do that by putting a break line, like I said, and then you click this little debug icon. And then what happens next is really cool. Yes, allow access to the debugger, please. Thank you. I like to have my debugger window separate from the... Oh, where'd it go? How do I change it back? Oh, shoot. How did I do this last time? How did I have you be double? There we go. There we go. So what I like to do is I like to have my debugger split so that, and you'll see this here in a second, I'll have my output over here, Turk, 250, Judy. And then what happens here is really interesting. It converts, it converts to debugger mode. So in debugger mode, this variables window shows up here. Frames, yeah. This one's not really relevant right now. But see, I can see all of the variables that I have just created up to this point, right? And now I have a few controls with the debugger. There is step over and step into. These are the two main ones that you're going to use. And then there's another one here called resume program, which means keep going up till the next breakpoint or the end of the program. So step over, this is the one you're mainly going to be using right now. Step over, all that does is it executes this line and stops at the next one, or stops before executing the next one. Step into is if you have a line that's a method that, and actually we'll do it, I'll run the debugger again, stop and rerun. Turk, 250. If I say step into, Oh, it doesn't actually show it. Okay. Step into basically jumps into the method and shows you line by line what that does, but it's not letting me go into the scanner one for some reason, and that's okay. See that game, JV. Anyways, if I say step over, click that, look, it executed this line, and now in our variables list, we have pi. And then we're going to have casted pi, then we're going to have double x, and then we're going to have casted int, or casted x. And when we skip again, we reach the end of the program. And that's a very quick and dirty overview of how the debugger works in Java. It's a really, really cool tool. And especially once when you get into stuff where you have to worry about flow control, like with conditional statements, method calls, etc., and you're confused about why variables aren't appearing the way you are, your program's not behaving the way you expect it to. This is a really cool tool, very useful to be able to jump through and understand by seeing how your computer is reading your code. And that can help teach you, okay, this is how my machine thinks about it. It's different from how I think about it. And you can kind of try to adjust your thinking, because ultimately you have to think like a computer. That's literally what we do here in computer science, is to train you to be able to think like a machine and understand how the machine thinks and processes things so that you can write code that best suits the machine logic. You can bridge that gap between human brain and machine brain, which is a really cool and sometimes frustrating exercise. That's kind of it. I know I blew through a couple things at the end. If you guys do have questions, please feel free to ask. Otherwise, I'll set you loose for the weekend, or for the week, I should say.
A really quick question.
Mm-hmm.
So can you scroll upwards, please? So when you created a new object, basically, like going back to your previous analogy, the mugs, or say a class, and you created a new instance, so kind of a new mug.
Yes.
Am I thinking about it the right way?
Yes, that is actually the right way to think about it. Scanner defines what a mug looks like. When we create a new instance of it, we manufacture a physical mug, right? Scanner just says, okay, a mug is a ceramic thing. It's got like a cup and it's got a little holder for it, right? It'll have a certain size, a certain dimension. And then when we say new, we're actually manufacturing a physical mug. You know, in this case, we're manufacturing a mug that's brown, has like little animal carvings on it, looks like a tree, and has a mug as a little handle that looks like that. So you are on the right path. Yes, that is the right way to think about this. Don't worry too much about the new class stuff with this one. This we'll get more into later in the semester when we get to actual classes, but that is the right way to think about it. Yes.
Okay, thanks.
Thank you, Jamie. Any other final questions?
So do we have to do the name section using that sort of integer addition to swap the values, or can we just use the to upper?
You can, but that would require you to use loops, which you haven't learned about yet. So for this one specifically,
okay,
you don't need to do it that way, I'll say, just because I want everyone else to look up the other methodologies on their own.
Okay, I just had to double check because I was like terrified of like how the heck I was supposed to do that without loops.
Yeah,
because we're talking about
you could
that.
do it with loops. I mean, it's a good exercise to do. But,
no, it is. It's just like we haven't learned loops in class yet, and I was like,
exactly.
How the heck are we supposed to do that?
So yeah, that's where Google comes in, right?
Yeah. Okay. Thank you for clearing that up.
No problem. By the way, if anyone in here is not set up in the Discord, let me know. I think there are still a few of you. Yeah, there's like 11 people who still have not chosen a role, so they don't see anything in the Discord. If you are one of these people, Azushka Dikisha Germila, Hamanta Thapa, Jeffrey Maurer, Gerald S., Jesse Kaka. You don't have the Discord? I'll give you the link here in a second. Jimmy W., Joshua, Lei Gao, Nyan Lin, or Pi. If you're any of these people, please make sure you select your role. And for those who don't have the Discord, I'll post a link here in the chats. So I'll put it up over here. What you have to do is you go to the Discord and you're going to jump into here. You're going to select your section. For you guys, that's section 7. And then it's going to give you your role. And then you'll be able to see all of this stuff over here. And here people are talking about the homework, asking questions. I respond every now and again. I used to respond way more in the past, but then it became a crutch. If you guys really, really need my help, ping, but be forewarned, if I feel like you haven't Googled it yet, most of my questions will be leading you back to Google and telling you, get back to me when you've read a little bit and if you still have questions about what you read. I know for some people that's incredibly frustrating to have your teacher tell you that, but one of the points of this class is to teach you guys how to bridge the gaps in your knowledge on your own, because there's not always going to be a teacher there to help you. Okay. If there's nothing else, going once, going twice, I am going to call the session for today.
Oh, thank you, Professor.
Thank you, sir.
Have a good weekend, everybody.
Thank you. Thanks so much.